Okay, so we want to move forward and we want to talk about looping. Okay, or iteration. So what is looping or iteration? Anybody want to state what? Yeah. It is right, based on, correct. So we identify that iteration is where we repeat instructions based upon some condition being fulfilled. Whether that condition is known in terms of how many times it should repeat, or unknown as in we don't know when that condition is going to be filled, changes the type of looping that we utilize. And that goes into categorizing them as bounded or unbounded iteration. So we have iteration, which is looping, and we have two categories. Oh, so I could have just been using my hand all this time. Nice. We have two categories which include bounded iteration and unbounded iteration. What is bounded iteration? Bounded iteration is where a set value has been given beforehand for the amount of times that an instruction should repeat. Okay? So it's a set value given beforehand for the instructions to be repeated for the number of times, right, the instruction should be repeated. So we have a set value given beforehand for the number of times an instruction should be repeated. Whereas the unbounded iteration waits until a criteria can no longer be met to stop looping. All right, so a good example of this, right, is if I take a look at Jeremy and I say, Jeremy, clap your hands 5 times. Right. In Jeremy's head, there is a counter. And Jeremy says, okay, is the counter starts at 0, and is the counter 5 as yet? Right? Or is the counter the value, before 5? Let's start at 1, sorry. So his counter starts at 1, he says 1, and he claps. Then he increments that counter to 2. Then he claps. To 3, then he claps. To 4, then he claps. Then to 5, then he claps. And he's like, I'm at 5. I need to stop right now. Yes? Okay? You are Emily? Right. So Emily, I'm saying Emily, wave your hand until you decide to stop. Stops right away. Alright, I'm not gonna keep on waving just for Sue's entertainment. Alright, this is unnecessary. But thank you, Emily. Emily has shown us unbounded iteration. I don't know when Emily stopped. Emily's favorite thing in the world could be waving her hand. She's like, I can't believe Sir asked me to do this. Right? I love waving my hand. Alright? And 2-3 hours from now, she's still waving and she's like, this is the favorite thing in the world. Alright? And then she decides to stop right before she falls asleep. I have no control over that. It is a criteria that the only criteria that needs to be met to stop is that she no longer wants to wave her hand. I've set things in motion. So it could be in terms of a programming or a computer application for this, it could be that I have a file to read and I don't know how many lines of text are in that file. But I do know that every line of text needs to be read from that file. So I would tell the computer, as long as there is text still in that file, read a line of text from that file. Somebody could have sent me a file with 1 line. Somebody could send me a file with 500 lines. Somebody could send me a file with 5,000 lines. The only thing that I know is that at some point the criteria could be met to stop. And that is important because remember, going back to our algorithmic rules, one of the things is that you have a finite number of steps. So I just need to know that my unbounded iteration could lead me to stopping at some point. However, if I write my code incorrectly, we could get led to something called indefinite postponement, right? Or an infinite loop, where we've written a piece of code that the criteria will never be met. Okay, so let's say, for instance, I set a counter and I said, when this counter reaches to 0, stop this loop. But my code is always adding a value to the counter. What is happening is that my counter is always moving away from 0. That's bad code, right? The problem is you as the programmer, okay? And the problem is always you as the programmer. Alright, again, not a line to go quoting to your parents that Mr. Val is saying. Mr. Val is saying, class, the problem is you, mommy. Alright? This is programming rules we are talking about. If your code does not work, you have to look within and say, what did I do wrong that is causing my code not to work, right? This is not, 2 classes ago, wherever we had relationship advice or whatever, and I said, I'm not here for that. No.
I'm gonna think about it. This is the parenting process.
No, you see, it done putting me in trouble. Listen, I am, once this recording is working, let it be shown that I put out my disclaimer. Alright, thank you. Today is the 11th of November 2021. Mr. Valdez is saying. Alright, good. So these are our 2 types of iteration. Let me just get the time.
52 minutes left.
Alright. So we're just going to take a look at the 3 structures that we use, and then that would be it. Okay? For bounded iteration, we use the for loop. We use a for loop for bounded iteration. And our for loop has basically 3 parts. And we have to use a counter. Our for loop is structured like this. For counter is equal to start value to stop value, right? We have an increment. So this is how our for counter works. For our counter, which is a variable, which is assigned to a start value, and it goes until a stop value, and it increments by a certain amount each time, we want to do an instruction. And then we say end for. And what is this useful for? This is useful for scenarios where we can identify the amount of times we want to do this particular instruction. So if I want to write, say for instance, for example, a piece of code that will print out all values from 1 to 100. I want to write a piece of code to print out, right? So to display values 1 to 100, we will end up writing 4, sorry, not 4, int x. For x is equal to 1 to 100, step 1. So this step 1 here is our increment. This step 1 here is our increment. This 1 here is our start value. The 100 is the stop value. And what are we saying to do? We are saying to print x 100 times. But every time the value inside of x is going to change. Because it starts off at 1, it'll print 1, and then when it hits the end, it checks. Am I at 100? No. Go up by the step. Print x, I'm at 2. Am I at 100? No. Go up by the step. Print x, I'm at 3. I'm not going to do this 100 times. Right? Until it reaches, I'm at 99. Am I at 100? No. Step up to 100. Print x. Go 101. Have I passed it? Yes. I've reached. I've done the instruction for the stop value time. Okay? So, in this instance, we can assume that the stop value is inclusive, which means that we will do the instruction on the stop value. Everybody good here? No, but this will allow us to manipulate arrays. So we're going in that direction, but we're not there yet. Right? This is still dealing with just straight regular variables. Any questions on this? As I say, this is just our introduction, eh? Okay. Alright, so the next thing that we have is that we have unbounded iteration. An unbounded iteration tends to use 2 different loops. We have the while and the Do while, yeah. Okay, so we have the while loop and we have the do while loop. So we'll take a look at the while loop for now. So the while loop. And the while loop executes instructions zero or more times. It executes instructions 0 or more times. Okay? And we say it takes the structure while condition is equal to true, do instruction. And if. So just to stick with the example that I had earlier on, for the purposes of brevity and finishing the class not too far after 3 p.m., we will say for our example, we could use the example of reading instructions from a file. A file could have 0 lines. A file can have 1,000 lines, 10,000 lines, any finite number of lines. We could say while, this looks like white instead of while, so hold on. We could say while file is not empty, do read line from file, and while. Why did nobody tell me I put end if up here? Oh my gosh, that's the worst possible answer. You're the teachers, right? I'm asking. No. Oh my, but you can prove me wrong.
That wasn't in there definitely.
Alright, Emmanuel in the back there challenged me earlier, you understand?
You didn't prove you're wrong. That's
oh my, so what, did that break your spirit? Yeah. Alright, okay. It's not like if you all challenge me in class about something, I'm going to say no and then bring you up in front of the class and battle to the death or something.
And you get shame, and then when I look into Google, you pass on the mirror and hit me.
No. I know it. First of all, you're safe until you graduate. Second, I want the encouragement. If I make a mistake, say it, because sometimes my brain is absent. Well, yes, I can't lose my job then. Yeah. Some editing know how to go on in this last section. Yeah. Yes, we are all laughing. I'm describing what's going on. The students think this is hilarious. All right, good. When I see it posted online, you will see sections of this redacted. Trust me. All right. So our while condition is equal to, so this is the while. And then we have the do while, which is like the while, except it executes instructions at least once. So a do while loop executes instructions 1 or more times. And some of you all might be thinking, well, so how in the world is that useful? Right? But it is useful. There are instances where you must you must have to do something at least once and then possibly some more times, okay? In terms of computing, it's useful for like showing menus. When your computer program starts, your menu is shown. But then the user could choose the option to exit one time. And but it had to show at least once. Okay, so that's one of the places where you will be able to use a do while loop. So you do while loop. Okay? Execute instructions one or more times. And the structure of the do while loop is that we have do, the statement do up to the top here, and then you put your instruction, and then you say while condition is equal to true. Okay? And sometimes if you go on and you read up on your own, especially with pseudocode, in some places you might see this called a repeat until loop. It's the same concept. Okay? The repeat until, but however the words for repeat until is usually the condition inside here is usually inverted. Right, so it's repeat until a condition is no longer true. Okay, but with a do while a condition is true. Alright? Just something to note. But it's the same concept. Okay, so that you do the instruction while the condition is true. So the last thing that we do is just write down the example for the menu. So you could do something like do, so this is your example, do show menu options. While exit is equal to yes. Okay? So I know that I used a function here, just allow me. But it's based upon what we talked about. Do show menu options while exit is equal to yes. Okay? So it means as long as the user has not selected the menu option for exit, because it indicates a function. Alright? It indicates, yes, some computer function, some piece of code that will be called later on. So what's that? It'll just be like I have the actual code to show the menu options in another block of code, in another named block of text. Right? Don't get hung up about it now. Focus on this. Show menu options. Right? We will learn how to do functions. Trust me, because the IA needs 5 functions. Yes. No. It's do while. And you will see how C handles it in terms of closing it off as a statement when we get into C. Once you hit the while. Exactly. Yes. Yeah, no problem. Any questions before we officially leave, close off?